Sure, I'm a principal engineer and software architect at Intel, and basically I work on the design of parallel languages and runtimes. No, I think it's always useful to generate scalar versions of code, and there's a proliferation of different binary formats. You can never control which versions get generated into your binary, so you don't have to generate versions you don't need. Now, regarding the atom is actually very important to Intel because it is the foundation of our efforts in phone and tablet, or at least there's actually two kinds of tablets: the atom-based tablets and maybe Ivy Bridge-based, ultrabook tablets. Ultrabook convertibles. So, but anyways, there's a continuum there of different processors at different power points, and Atom is and will remain important to Intel. And Atom does support SSC instructions and vector instructions as well, so it's totally reasonable to target that compiler. In fact, we've been doing a lot of effort in optimizing other compilers to target Atom as well. Actually, the efforts we're making in Silk Plus programming model is to create an abstraction layer that you can express your parallelism at an abstract level, not worrying about how wide the vector units are or how many cores you have. Just say, here's the parallelism. And then the compiler is then tasked with the job of figuring out how to best use that parallelism on the physical parallelism of the device. Intel has a long history of backward compatibility, and that is still an important thing going forward. But one thing that we're doing lately with our languages is trying to make them a bit removed from the hardware, give us a little bit more room to innovate under the covers in the machine language level. And you will certainly see, extensions to the vector part of the instruction set, especially as we go from SSC to AVX and to future versions of AVX. So the vector units are getting wider and they're getting more powerful. That gives us more opportunities for getting higher performance on a single core. And of course, with multiple cores, we're also introducing new things for synchronization between cores that can also be used by these runtimes. But that means we want to have some common place for software developers to write their code and not have to rewrite it for every new processor. So that's why our investment in parallel computing languages is so important. Oh yeah, and in fact, the Atom has been greatly raised in priority, and it's going to be accelerating in its capabilities. And certainly you're going to see some really interesting new Atom processors coming out in the phone and tablet space. And Intel talks about something called the compute continuum, which is like, we want to have the same kind of software development methodology and the same kind of processor methodology spanning a very wide range of devices from supercomputers down to phones. And so the ultimate goal is the software can be written once, maybe tuned it a little bit, but basically the same code can run all across the entire continuum. Power in the sense of performance, yes. The ratio between power and performance is actually nonlinear, power in the sense of watts. And so the Atom definitely is turning down the expenditure in watts, but actually you're not losing as much performance as you would think. So per watt, an Atom is very, very efficient and can deliver a lot of performance for actually a quite small amount of power.